previous presentation, Steve gave an excellent presentation on the need of interface management, why do we need, and how we can implement it. I'm going to talk a little bit about the future of interface management and how we can benefit more from interface management, about the mechanisms that we can use. This part of my research is in collaboration and great support of Coreworx team, especially Kelly, throughout the last 3 years. And we started this research with the question and with the hypothesis that implementing interface management will lead to more effective risk management in mega projects. To answer this hypothesis, first we have developed a framework for interface management system, including the elements of IMS, the definitions, and the workflow-based system for IMS. Then we find the correlation between interface management system and front-end planning, and how we can use interface management and benefit from it in the front-end planning. Finally, how we can identify key interface points in a project, and how we can use those key interface points and connect them or integrate them with the project schedule. And finally, I'm going to talk about a little bit on the CII Interface Management Research Group and the report out that we're going to present in July 2014. As Steve and Teresa mentioned, construction projects are becoming really complex right now. They are larger in scale, and they have lots of stakeholders involved in the project execution. They're dealing with condensed schedules. And in addition to these complexities, we have several risks that they have, like sources imposed to the project. The sources of this risk are majorly ineffective communication between stakeholders, poor work relationships, and ineffective person-to-job mismatch, and also the failure to clarify the expectations between these stakeholders. If we could manage these complexity and risks in a project, we'll eventually have a successful delivery of the project. But this is not happening all the time, and sometimes we are having disasters like this. In order to avoid these disasters, we need to have an effective planning, designing, constructing, and management paradigms in the construction management of capital projects. And electronic product and process management systems are evolving recently, and they're working on a workflow-based system to formalize the communication and the delivery of the project. And one major aspect of electronic product and process management systems is interface management system. Interface management, we define it as a systematic, workflow-driven process to formalize and automate the communication between project stakeholders, to effectively identify and handle interfaces throughout the project lifecycle. And the objective of the IMS is going to be increasing alignment between project parties, having more effective communication and cooperation between them, added visibility on the roles and responsibilities and the deadlines of the deliverables, and eventually reduce risk in the project execution. Our interface management system is going to have several elements, as Steve mentioned. So between every pair of contract packages, several interface points are identified. And by interface point, we mean any soft or hard contact point between two interdependent interface stakeholders. For every pair of interface points, we can define several agreements. And the agreements are a formal and documented communication between two interface stakeholders, and they include the deliverables, description of the deliverables, the required dates, and required actions to successfully deliver those deliverables. And finally, we have interface agreement deliverables. And these deliverables are single pieces of items, information, or activities that we need to implement or deliver to provide the requirements of that interface agreement. And we can have interface management defined at different levels. The first level that I'm going to talk about is inter-project interfaces. And this includes the interfaces that happens between the parties that are directly involved with the project execution. For example, the owner and the contractors, or the contractors themselves. And the second layer is intra-project interfaces, which happens between the disciplines of a single organization, for example, one of those EPCs. And the third layer is the interfaces between the project parties and the outside organization, like government, regional organization, to get permits. For the purpose of this research, we mainly focus on the inter and intra-project interface points. As I mentioned, interface management is working on a workflow-based system and includes 6 major steps. The first step is identifying interface points. The sooner we start this process, the better results we're going to get throughout the project lifecycle. The owner and the owner representatives starts to identify interfaces throughout the front-end planning, and they gather all the required information and document them. Who is responsible? What are the deliverables information? What are the need dates? And once the contracting party is awarded the contract, all the package is transferring to the contracting party. Then it's the contracting party responsibility to go through all the documents and approve the adequacy of those information. They can modify some of the information, add some more interface point to the system. And once they agreed on all the interface points and the information, they start to communicate with each other by issuing interface agreements. Throughout the whole process, we have developed several criteria to measure the performance of interface management. Who is doing what, how many of interface agreements are overdue, where are the bottlenecks. And finally, when all the agreements are closed and all the parties approve that all the requirements are delivered appropriately, we consider that interface agreement closed, and finally the interface point closed. By having a workflow-based system, we facilitate the mapping of information flow between interface stakeholders. We also added visibility on the roles and responsibilities and the need dates of those information. We can also provide an automatic alert system on the task to be done, on the overdue agreements, and for example, we can easily identify unnecessary cycles of information. For example, if there's information going back and forth between 2 parties, we can easily identify, okay, there is like more than 10 times circulation of information between these 2 parties, so there's something maybe wrong between them and we have to interfere with them. And we can add traceability, we can increase the traceability of the information and flow of the information, and we can identify bottlenecks and we can easily track them. Now that we have our interface management system framework settled down, the question is that when we have to start interface management system, as I mentioned, the sooner we start, the more benefit we're going to get from that. Front-end planning, especially the conceptual phase, is the best way to start, the best time to start interface management system. But we have to remember that it's an iterative process and should go through the whole project life cycles. We can always identify new interface points, we can create new interface agreements, but we have to make sure that we put it in the system. But we have like several questions that comes into my mind. How we can use interface management during front-end planning? As you know, like a project can be divided into several scope packages, but how we can optimize those scope packages using interface management system? Who we have to assign the complex the scope packages, and how we can monitor the performance of our stakeholders. To address these questions, what we propose is to use social network of project parties. And social networks are one of the good tools to visualize and analyze the relationship between different entities. And by entities here we mean project scope packages or project stakeholders. And the nodes here represents scope packages, and if we go later in the project, different stakeholders. And the lines between them shows the interface point between every pair of scope packages. As Steve mentioned, we have 2 roles defined between 2 contractors that they have interface relationship with each other. We have leading party, which requires the information, and we have interfacing party which provides those information. And as you can see, these lines, they're directional and going from the leading party to the interfacing party. When we created the network of interface management, we can easily analyze to identify the critical scope packages in that network. We showed the application of this methodology by using a model offshore project. In this project, we have identified almost 500 interface points at different disciplines of electrical, pipeline, turret and mooring, and well system. What you see is a small snapshot of the network of the scope packages and interfaces between them that we have identified. It's really complex, even like just for 500 interface points. And I assume for larger projects that involve like thousands of interface points, this is becoming more complex. So what we propose is that we add up the similar interface points on the lines, on the edges, and then we have a weighted network. And as you can see, these are color-coded, and we can assign each color to different disciplines. When we created this network, we can analyze the network through the centrality concept. And the centrality concept shows the distribution of relationship between nodes in the network. Or in other words, it shows how involved every single scope package is in relationship with other scope packages. And throughout this analysis, we can define two types of scope packages. The ones that has lights out degrees, or they have more leading responsibilities, and the ones that has more interfacing responsibilities. If we analyze the example that I showed earlier, then if you consider all the interface points and the complexity of the interface points, we can see that EPC2 or the scope package 2 gonna have more responsibilities in the leading positions. And EPC3 gonna have more interfacing responsibilities in our network. Or for example, if we focus on the electrical interface points, we can see that EPC3 or scope package 3 has the main dominant role in both of the responsibilities. So what we need to do is we have to make sure the scope package of number 3 should be assigned to a stakeholder that is highly capable of managing the interfacing and leading positions in managing the electrical interface points. The advantages of this methodology is that we can run the analysis for different scenarios of dividing the project into scope packages, and we can use the scenario that has less complex relationship in terms of interface points. And we have to make sure that the complex scope package is assigned to appropriate contractor throughout the for that project. And also, we can analyze the performance of stakeholders once we are going into the project lifecycle. When we started the project lifecycle, we can see who is doing, most critical job in the leading interface points, and also like answering to those interface points. The other question that comes into mind is that, okay, we have an interface management system and we divided our project, and we have selected scope packages with less complex interface relationships. But how we can benefit more from that? What we noticed that interface management is an effective tool in reducing and eliminating or anticipating some project risks. And we achieved this goal by because of added visibility on the roles and responsibilities of the parties, and also the deadlines. We have clear boundaries between stakeholders, and we have like specific and documented dates. So eventually, we're gonna have less amount of rework, and we're gonna have some time savings in the project, and finally, we'll achieve the cost saving. So it seems logical to focus on the time saving and correlate interface management to the project schedule to anticipate some of the project schedule related risks. But the question that comes up here is that How we can do that? In a project that there are like thousands of interface points and eventually several thousands of interface agreements and several thousand of tasks, it's not possible to correlate every single activity to every single interface point. It also increased the complexity of the calculation. But what is the solution? The thing that we know here is that interface management provides us with more real-time information and cyclic information between project stakeholders. And what we want to do is that we capture those information and correlate to the linear information direction of the CPM or project control. To do that, again, we propose using the network of interface points. And in this model, instead of stakeholders on the nodes, we have the interface points on the nodes. And the edges shows the interdependency between those interface points. And we believe that those interdependency is a measure of risk because of their cascading impact potential on the interface point themselves. Like consider the dependency between tasks in the critical path method. And by interdependency, we mean any logical information, any logical relationship between every pair of interface points. So this interdependency could be dependency of information flow, it could be time dependency, or it could be space dependency. For example, two interface points may occur at the same location, so those are dependent based on their location. And also, it could be because of the sequence of tasks. If we could capture the interdependency between those interface points in a matrix like this, we can easily create a network of interface points. But we have to make sure that the interdependency relationship is a directional relationship. So some of them are just in one direction, some of them in two directions, as opposed to the project schedule that's one direction. And when we created the network of our interface points, we can identify two types of key interface points. The first one is high impact interface points. And by this one, we mean if they collapse or if they have a delay, lots of other interface points gonna be delayed. And we have risk-prone interface points, which are their performance is highly dependent on their predecessors. So any changes in their predecessors or any delay in the predecessors will have an effect on this interface point. We created the model and then we run the analysis and we identified two types of high impact and risk-prone interface points. And throughout the network, we can easily show them with different colors, with larger nodes, or even with bolder text. And we can visually represent what are our key interface points there. And once we have defined these key interface points, because they have cascading information flow of the other interface points, we can easily use them and correlate them to the project schedule. So what we did, we defined interface milestones on the project schedule at level 3 and correlate these key interface points to the project milestones. And as long as the end date or the closing date of our interface points are smaller than the milestones on the project schedule, we are fine. But at the moment that any changes happens on the interface points and the date change and the date is going after that milestone, then an alert system will automatically send to the project managers and project interface managers. And they're going to have a meeting to see if they can push back the date or not. If not, then they're going to have an interface meeting with all the projects involved in that interface point to update the schedule and give solutions to resolve the problem. We tried several times to implement this methodology on different examples and different projects. But unfortunately right now, because interface management is an evolving paradigm in construction management, we couldn't find a project at the appropriate stages of their life cycle to implement this methodology. So what we did, we kind of summarized several offshore projects to create our own offshore project, and the one that's used in previous example. So we have developed 8 scope packages for this project, and we have identified 16 very, very high-level interface points. We created the network of the interface points using the interdependency of them to identify the critical interface points in the system. So as you see, for example, the interface point between utilities and topside is our high impact and also risk-prone IP, and the topside shipment could be one of our risk-prone IP because it's highly dependent on the other interface points in our system. Then we created a schedule for that. We identified the milestones on the project. We linked the key interface point to those milestones, and we watch and monitor the progress of those interface points to make sure that they don't go beyond the time of our milestones. As a concluding remark for this part of my research with Coreworx, we have developed a workflow-driven process for interface management. And through that, we added visibility on the roles and responsibilities and dates of the project deliverables. We have introduced 2 networks, and we analyze the networks to identify what are the core critical scope packages in the project and what are the key interface points in our project, and how we can benefit from those key interface points and correlate to the project schedule to anticipate some project schedule-related risks in the mega project execution. As I mentioned and Steve mentioned, interface management is an evolving paradigm. So there are lots of unanswered questions in these fields. Like some of these questions is that who should implement interface management? I mean, what level of interface management each organization should employ? What are the key attributes of interface management for successful project delivery? How we can assess our interface management if we have one in our project? And what is the actual relationship between interface management and improving project performance? These questions, which is another part of my PhD studies, is in collaboration with Construction Industry Institute. And CII created interface management research team, or IP302, with this, and the team in May 2012. And the team started with the essential question is that what practices, techniques, and processes are most effective to improving critical interfaces among globally disparate project teams, multiple project partners, and increasing the diverse labor force? To address, our team consists of 20 members from 17 companies and 2 universities from all over the world. We have members from South Africa, from United Arab Emirates, from Brazil, Canada, and US. So you can see it's a diverse team and lots of organizations are involved in this research group. To answer the big question, we have studied 46 projects and we interviewed them throughout a developed questionnaire. And these projects are from different sectors of the industry. They have different sizes and also different contracting and delivery strategies. For example, these projects, as you can see, the distribution of these projects are somewhere like it starts in an oil industry. We have metal refining, chemical manufacturing. Even we have considered dam project, hospital, nuclear projects. And their sizes vary somewhere between over $100 million to a little bit over $10 billion. So it's a wide range of projects. We analyzed their contracting strategy and delivery strategy, and the most common delivery strategy is EPC and EPCM between 46 projects. And the common contracting strategies are lump sum and reimbursable work. When we gathered all the data of our interviews, and we analyzed them, and our major objective here was that we wanted to know who should implement interface management. To answer this question, we have considered 4 main aspects. We've considered the size of the project, organizational complexity, what are the risk and complexity factors that could affect project to have interface management, and the delivery and project lifecycle strategies. And we also provided an interface management implementation guideline, or we call it image. The image has is based on the analysis of the interview of those 46 projects. Based on the interview results, we have developed interface management maturity model. So we have different levels for interface management, and then we created a tool which we call it peer matrix, and it can be used by organization to assess the complexity of their organization and define what level of maturity they want to have in their project. We developed another project called ICAT, and it can be used by organization to analyze the complexity of their interfaces between every pair of their stakeholders. And finally, a roadmap for the organization how to develop interface management and how to implement it throughout the project lifecycle. This is a snapshot of our ICAT tool, which is used to assess the complexity of interfaces between every pair of interface stakeholders. And the answers to those questions gonna be reported in CII Annual Conference, which is happening in July 21st to 23rd in Indianapolis. Thank you very much for listening to my presentation, and I'm open to your questions.